Hello there, this is Mrs. Sharp, and these are the notes for Learning Target 5.1. And here's what we're going to do in 5.1. First, define a chemical bond. Then, define an ionic chemical bond. Define a covalent chemical bond. And predict when an ionic bond or a covalent bond will form. I'm excited. I hope you are too. So let's define a chemical bond first. What is it? It is a force that holds two atoms together. And this definition is intentionally vague. Doesn't say what kind of force, it just says a force. So it is a force that holds two atoms together. In fact, we could even say two atoms, or we could say, or ions, because some have charged atoms that hold them together. The thing that I want you to know is that when two atoms join together in a bond, their properties change. And the example I have for you is sodium plus chlorine, the elements, making sodium chloride. This is a really interesting reaction because here, these are called your reactants, remember? Over here on the reactant side, the things that do the reacting, you have sodium metal, it's a solid. And you have chlorine gas, which is diatomic. That's what that 2 means. And chlorine is a gas. And sodium is so reactive that actually when it hits water, it makes hydrogen gas, which is explosive. So a lot of times when it hits water, it actually catches fire. Chlorine, as you can see, this yellow gas is extremely toxic, fatal. And then if you put those two together, by putting those two together, and this should illustrate how vastly the properties can change in a chemical reaction, it is sodium chloride, which you eat every day. So sodium chloride is made up of these crazy intense elements, but when you bond them together, their properties change so much. I mean, the color, the odor, the texture, all of these things change and the properties completely change. So a chemical reaction then is a chemical change where old bonds are broken and new bonds are made. So these old bonds, sodium right now in this example is not bonded to anything. It's just a plain old sodium atom. But chlorine, this little 2 right there, when you see little 2 or a little number of any kind of subscript, that's going to denote that those two chlorines are actually stuck together. So they are actually stuck together, and that stuck togetherness is the bond between the two. So that's the bond. Cool. So if I break that bond and I make a new bond between Na and Cl, that's going to cause the properties to change. So that Cl, instead of being bonded to a chlorine, is now bonded to a sodium. Cool stuff. Okay. So let's talk about why atoms would want to form a bond. And the answer to that goes back to sweatpants. Atoms want to be in the lowest state possible, the lowest energy state. And so when they're in a low energy state, that means they're very stable. And when they're in a high energy state, that means they're very unstable. So because atoms are lazy, they would only form bonds if it helps them achieve a lower energy state. If it helps them do that, then they will form a bond. If it does not help them do that, they won't form a bond. Here's an example of a bond being made, and this is the example that I showed you in the last slide. So when sodium and chlorine bond together, what I have here is a potential energy diagram, and this is called a reaction coordinate because from left to right, it's the start of the reaction, so these are your reactants, to the end of the reaction. And so sodium and chlorine, if you were to add up their energies together, you would have a higher energy than sodium and chlorine when they're bonded together. So that means that Na and Cl2 are less stable because they have more energy. So those two things are inversely related. They have more energy, so they are less stable. And sodium chloride has less energy, so it is more stable. That means when you make sodium chloride, and you're going down in energy, that energy has to go somewhere. Remember the electron going from a higher energy to a lower energy, and it threw that energy off. Well, in this case, energy is released too. And remember our term for that we've discussed all throughout the year is that when energy is released, that is an exothermic Exo means out, therm means heat. So it is an exothermic, an out heat or an out energy process. So when you make a bond, it's always exothermic. Making bonds is exothermic. So that means when you break bonds, going the opposite way, it must be endothermic. So let's take a look at that. I've got the Cl2. Remember that 2 means that they're stuck together, and breaking them apart into Cl plus Cl. Now in chemistry, a plus means an and or it's a separator. And I can never spell this word separate. There we go. So anytime you see an and, that means that those two are separate. There's a chlorine atom and another chlorine atom. So when I look at the reaction coordinate here, if I start with Cl2 or Cl bonded to another Cl, that has less energy, or it is more stable than two chlorines that are separate. So they have more energy when they're separate. So they are less stable. So those chlorine atoms aren't really going to want to do that. So just like the electron did not want to go up in energy level, these don't want to do this either. So energy is needed. So we're going to have to like coerce those chlorines to break apart. So energy is needed. And by the way, that energy has a fancy term. It's called the bond dissociation energy. Dissociate means to break apart. So if you want to dissociate from your parents when you are on vacation, that means you don't want to hang out with your parents on vacation. So bond dissociation means bond breaking. So the amount of energy it takes to break a bond. So since energy is needed, it's going in. See how I have my arrow in here? Energy is going in. That is called endothermic, or in energy. Cool. So there are two types of chemical bonds we're going to talk about now, ionic and covalent. An ionic bond is the electrostatic force that holds oppositely charged particles or ions together. So an ionic bond is made up of ions. Now electrostatic force means between opposite charges. That's what electrostatic means. Electro for that charge, and static means it's staying in place. So it's between two opposite charges. So since they're attracted to each other, that is the bond. Now what you're looking for in an ionic bond is one metal and one nonmetal. That is your guiding factor. So in this case you have sodium, which is a metal, and chlorine, which is a nonmetal, and they're both ions, so you have an ionic bond. Now because you have a metal and a nonmetal, the key to this is looking at the difference in electronegativity between the two. It's got to be large. It's got to be so large that the one with the greater electronegativity is actually going to steal an electron from the one with the lower electronegativity. So if we look at chlorine, chlorine has an electronegativity of 3.0, and sodium has an electronegativity of 0.9. And this comes right off your periodic table. On the front, bottom right-hand corner of each element has the electronegativity. And remember, that's the ability to attract an electron. So if chlorine and sodium are fighting over an electron, chlorine is going to be a big old stud muffin, very good at tug-of-war, and sodium is going to be kind of a weenie. And so when they're tugging on that electron, chlorine's going to pull really hard, in fact so hard that he's just going to rip it right away from sodium, the weenie. So that's going to give chlorine the -1 and the +1 charge. So then we'll have an ionic bond form between them. Now the cutoff number for that, and this is just a guideline, is 1.7. But I wouldn't look at that as much as maybe looking at this metal and non-metal part and knowing that the difference in electronegativity is large or larger. Like in this case, the difference is 2.1. That's pretty large for a difference. So let's get some examples of ionic compounds you might know. Of course, we've talked about sodium chloride today. How about magnesium sulfate? That's Epsom salt. Potassium chloride is a medication for heart patients, but they also use it for lethal injections. If you have too much of it, it can actually cause your heart to get into trouble. So notice that all of these have a metal and then a nonmetal. In this case, 2 nonmetals. So how do covalent bonds differ? Well, atoms in non-ionic compounds will satisfy the octet rule by sharing pairs of electrons instead of stealing. So remember, the octet rule is that they want those 8 valence electrons to be stable. So instead of stealing, they're going to share. And that's because their electronegativity is small. So before we talk about this right here, if the difference in electronegativity is small, so between 0 and 1.6, let's say we've got chlorine and chlorine. Chlorine's electronegativity is 3.0, and chlorine's electronegativity is 3.0. So that means they're equally studly in terms of tug of war. So what happens is when they fight over an electron, they reach a stalemate. Neither one is strong enough than the other to pull the electron away. So the electron is never stolen. Instead, it just stays exactly halfway in between the two of them, and it's shared. That happens when your electronegativities are close. You can also look for, right here it says, when 2 non-metallic atoms share a pair, and I'm going to say or pairs, a pair or pairs of valence electrons. So here we have water, H2O, and you notice that right here, where it's shaded in yellow, is a shared pair of electrons. So we would call that a single covalent bond. 1 pair equals 1 bond. So that's a single bond between O and H and a single bond between O and H. So that's a covalent bond. So some examples of covalent compounds, you know, water is one, carbon dioxide, carbon monoxide, dinitrogen monoxide, which is known as laughing gas or nitrous. Notice how they have all nonmetals there. Tricky one is hydrogen. Got to watch out for hydrogen, because even though hydrogen is a gas, it can act like a metal or a nonmetal. So on that one, make sure you check your electronegativity. Hydrogen's a tricky one. So to predict which bond will form, first find your elements on the periodic table. 2, determine whether the metals are a metal and a nonmetal, or 2 nonmetals. If you're not sure if you have hydrogen or a metalloid, then you can do number 3 if number 2 is not working for you. Then you can check the difference in electronegativity. Remember, if it's large, that means one should actually steal the electron from the other, so that would be ionic. If it's small, then it would be covalent. So I would like for you to try these ones right here, and we will talk about those in class. So go ahead and try those, and we will talk about them soon. Have a great, great, great night or morning or day or whatever it is. Okay, I love you. Bye-bye.